This video is going to focus on a couple of additional properties with exponents. One is called the powers to power or power to power property, and the others refer back to powers of, in one case, of products and powers of quotients in the other case. So we're actually going to cover three different situations here in this video today. So let's start with the powers to powers property. The powers to powers property essentially says that if you take a power, something like 4 squared, you can raise it to another power. And there's a rule that we will see that simplifies this. But let's take a quick look and write out what 4 squared to the third power looks like. We know that 4 squared to begin with, 4 squared looks like 4 times 4. And that would be raised to the third power more. So if 4 squared is 4 times 4 and it's raised to the third power more, then we know we're going to see this 4 times 4 repeated as multiplication in itself. So that's going to continue as 4 times 4, that's my 4 squared, times another 4 times 4, and then again times 4 times 4. That's going to be 4 squared to the first, the second, to the third power. Notice what we have by the time we're all done. We have a product of a series of 4s being multiplied. So what we essentially have is a power with a base of 4 raised to, well, whatever number of 4s that there are being multiplied. There's 1, 2, 3, 4, 5, 6 4s being multiplied. So to look at the end result, 4 squared to the third power just turns into 4 to the sixth. So that begs the question, can we look back at these exponents here and figure out a much quicker way of getting to the end result without having to go through all this? So the question is, therefore, how do we get to 6 as our final exponent in our simplified result using the exponents of 2 and 3? And I think you can quickly see that this 6 is based on multiplying the exponents of 2 times 3. So I think we've come up with a rule that we should be able to apply up above in these other examples. So let's actually skip these examples for a moment and let's write our rule. And then we'll go back and exercise that rule. Okay? So let's see. We want to start out by explaining what the scenario is. When a power is raised to another power, as was the case with 4 squared, that's 1 power raised to another power to the third. What did we do? Well, we keep the base. We kept the base of 4. And what did we do with the exponents? Well, we can see by the time we're done, we took the exponents of 2 and 3, we multiplied them, and we got our final power of 6. So multiply the exponents. So I'll tell you what we'll do. We'll look at one more of this grouping from above together, and then I'll leave you to do the other two on your own. So looking at the 3, I'd say the one that might cause us the most amount of trouble is the middle one. It shouldn't, but the fact that it has a negative base might throw us off. But just remember, our base is -2. It's raised to the 4th power. It's raised to the 5th power more. So all we're going to do is to take our base. We're going to keep the base of -2, and we're going to raise it to the 4 times 5 power. So our end result is going to be keeping the base and saying that's equal to the 20th power. So that's our final outcome. Nice and simple. And don't forget, with the negative base, you want to show that base is negative, continue showing that base is negative by keeping it wrapped in parentheses. So you'll use this rule and you'll quickly do the other 2 examples, and we'll check those in class. So let's move on. Our next power rule is taking a product of a base. Notice our base is made up of more than one term now. We've been used to seeing 2 raised to a power or x raised to a power, but now we have a product of 2 and x. Our entire base is in parentheses, 2x, all raised to the 4th power. So again, what's usually helpful is for us to recognize what this looks like as a product to see if it will help us to come up with a simpler rule. So if I think about this base raised to the 4th power, it's that base repeatedly multiplied. So it's that base of 2x, and the exponent says that there are 4 of them being repeatedly multiplied. So it would look like 2x times 2x times 2x times 2x. Now, if you go way back, and this goes back to the beginning of the year, we talked about properties. We had the commutative property, which said that we can reorder things that are being multiplied, and it's not going to change the effect. So what I'm actually going to do is I'm going to take all of my 2's. There's 1, 2, 3, 4, and I'm going to rewrite those for us as 2 times 2 times 2 times 2. And then I'm going to follow after that with the x's that are being repeatedly multiplied, times x times x times x times x. Now let's think, now let's work backwards. To simplify 2 times 2 times 2 times 2, that's nothing more than 2 to the 4th. And to simplify x times x times x times x, that's nothing more than x to the 4th. So think about what we essentially accomplished here. We started out with a base of 2x, all raised to the 4th power, and we wound up with the equivalent of each part of that base raised to the power. So it's the equivalent of saying that 2 to the 4th, x to the 4th, is the same as the entire base of 2x, all raised to the 4th. So the way we might describe this easily, and we're going to use the word loosely, is to say that we take this exponent and we distribute it, okay? So what we'll say is when different bases, and what I mean by that is the 2 and the x are different bases, different bases are raised to the same power, basically just, and I'm going to put this in quotes because this is really loosely speaking, distribute the exponent to each part of the base. So it's real simple. I essentially took that 4 and I distributed it to the 2. That gave me the 2 to the 4th, and I distributed it to the x. That gave me x to the 4th, and we're done. Real quick and easy. So we'll look at, again, we'll take the one that might give us the most trouble. This is the equivalent of saying that the negative 4 is raised to the 2nd power, and the z is raised to the 2nd power, and we're done. If we take a step back, this is the equivalent. I know you'd be tempted to say 2 times 3 is 6, all raised to the 4th power, but if we stay true to the rule, this is saying nothing more than 2 is raised to the 4th power times 3 to the 4th power. And if you want to put a multiplication sign between the two, you can feel free to. Okay, so that is another one of our power rules, our power of products. And we're going to see that this rule with the power of products applies also to the power of quotients. So without actually writing a rule, we'll do the same thing. We will take that exponent and we will essentially distribute it. So 2 over x as a fraction all raised to the 4th is the equivalent of saying 2 to the 4th over x to the 4th. Likewise, a over b all as a fraction to the 12th will be the equivalent of a to the 12th, b to the 12th. I'll have you finish that. And if we were to take this a step further, something like 4/5 all to the third power would be the equivalent of 4 to the third over 5 to the third. That would be simplifying. And then if we were asked to evaluate, well, now we need to figure out what 4 to the third is. And if we're getting comfortable with knowing our powers by memory, we know 4 to the third is 64 over 5 to the third is 125. Okay, so anything that's remaining on these notes, I'm going to ask you to finish up. You have enough examples that we work through to help you finish these notes, and we'll do more practice in class.